introduce Dr. Nancy Grimm from Arizona State University, who's going to help us end our day and our workshop by discussing the importance of merging concepts of resilience to meet the challenges of today. So she's going to focus on the need to strengthen the capacity of social, ecological, technological systems to maintain their essential structure and function when faced with extreme climate-driven events. Really excited to have you here, Nancy. Please take it away.
Thanks, Ben and the NCEAS team for the invitation. Let me just check that everyone can hear me all right and see the slides.
Yes.
Okay, great. So I have a real fondness for NCEAS that goes back to the very first synthesis symposium and my time chairing the Science Advisory Board, but it's been a while. I am an ecosystem ecologist. I study rivers and cities. I carry that label proudly, but I now spend a lot of time with these characters that you see on the slide here at the interfaces of very different disciplines or domains: social science, engineering, design, political ecology, futures, sustainability science. We specifically focus at the intersection of climate change, especially extreme events, with urbanization and urban systems. I'm going to speak to you today about our ongoing work, which is part of the SETS Convergence project that you see on the left. That is an outgrowth of the Urban Resilience to Extreme Sustainability Research Network. And this work is on a social, ecological, technological systems, or SETS framework that centers equity and nature along with built infrastructure to build resilience in the face of big challenges that we face today. So the good ideas here probably come from one of these colleagues, so I want to acknowledge them, but they should not be held accountable for any failings of this talk. So in this synthesis workshop, I'm mainly talking about synthesis as interdisciplinary convergence, or deep integration across the different theories, epistemologies, ontologies, approaches, and tools of diverse disciplines. I thought this talk was going to be out in left field for the workshop, but I was really happy to see these 4 questions or 5 questions emerging from the breakouts and the time that I spent in the breakouts discussing them, because you can see with the highlighted words here, many things that I think are highly relevant to what we're working on in this project. Well, as you all know, we live in challenging times. These are graphs that are sometimes called the Great Acceleration, where we see nonlinear changes in the activities of people on the left driving these nonlinear changes in the Earth system. And what characterizes this and is most obvious is this rapidly changing world, not only rapidly, but accelerating change. But what this doesn't show is the importance of feedbacks and interactions or interdependencies within the Earth system, which includes people. For example, the rise in surface temperature driving energy use or water use, or the degradation of the terrestrial biosphere driving urban population growth. 2 other characteristics are defining for this era of rapid change. First, complexity is increasing, the complexity of systems, the complexity of the problems, and increased uncertainty, the non-stationarity problem, for example, where the probabilities of extreme events are changing over time. For example, this graph from the Munich Reinsurance Company shows you changes in the frequency and magnitude of extreme events. All of the colored bar segments, except for the red ones, are weather-related extreme events. And so they're linked to climate change, although we know that there's problems with attribution of any given extreme event to climate change. We can say that the increase in frequency and the magnitude of extreme events is known to be an effect of climate change. And in fact, people experience climate change most immediately and urgently through extreme events. But there's an ugly reality that emerges when we look at the impacts of extreme events. Those who are least able to cope are disproportionately affected. And in this graph inset that you see from Sang in 2017, you can see US counties ordered by per capita income on the x-axis and the projected economic damage from climate change, which is highest for the poorest 10% of counties in the US. So my team has been working in urban ecosystems, and my talk today is coming from that perspective. Cities are particularly vulnerable to extreme events given their locations. Many are on coasts, along rivers and drylands, and their concentration of people and the infrastructure that people build. And the world is urbanizing. Most of the population growth in the next half century will be in cities, and most of that will be in the less developed world, or the so-called global south, which introduces this issue of international equity. Thus, the intersection of urbanization and climate change, especially in terms of extreme events, makes it really important to understand how urban ecosystems can build resilience. Of course, cities are where most of the people are, and most of the commerce takes place. Therefore, it's no surprise that cities often have been hotspots for the spread of COVID-19, our current crisis, meaning that the benefits of aggregation that have driven urbanization for so long now seem to be a detriment. So how can cities become resilient to this kind of extreme events? Almost certainly the kinds of strategies that are best in a pandemic are going to exhibit conflicts or trade-offs with strategies that are best in dealing with extreme events and climate change. And my colleague, Timon McPherson, who you see here as a climate hero from New York City, has related positive COVID cases to median income and percent people of color in the New York City area. So again, we see a disproportionate impact of COVID-19. And we're seeing similar documentation of disparities in vaccination rate, death rate, and so forth for communities of color. So given the rapid change, the interdependencies, complexity and uncertainty, and issues of equity and social justice, there is a strong need for convergence across social, ecological, and technological domains. And so for this reason, we are thinking the convergence of social, ecological, and technological systems. And you can see in the diagram in the center bottom here, social behavioral domain, a technological infrastructure domain, and ecological biophysical domain. Obviously, there's been a lot of work in social ecological systems, a lot of work in social technological systems as well, but less work that integrates all three of these. So I want to just sort of bring this to an example of today. And these are images that I took off the web in the last couple of days. This example is the heartbreaking humanitarian crisis that's unfolding in Texas. Did anyone expect Texas to have snow and massive power outages that have occurred there? Over 3 million people without power, people dying. Some would say this is evidence there's no climate change because it's cold, right? Which of course is nonsense. Others say it's the fault of the failure of wind power, which accounts for less than 10% of the power in Texas. So it's not that either. This is part of the blame game that's going on. Conditions basically in Texas now are exceeding design standards for the power grid. And this whole example from Texas illustrates how regional disruptions, such as this extreme cold event, can turn into extended and interlocked crises and continue cascading through multiple systems. So these power outages have resulted in differential exposure. This New York Times article highlights that the minority neighborhoods have been hit especially hard, losing power first and probably will have it restored last. This also has resulted in food shortages. For example, you see these long lines for grocery stores, transportation disruptions, which has resulted in inability to restock the shelves, water shortages, not just because of energy problems with, for example, pumping water and so forth, but the delivery infrastructure, the pipes that go to your house, not built for this kind of event. So broken pipes resulting in water shortages. And then access to shelter. You see variation in the ability to seek relief owing to financial capacity. So people that can afford to go to hotels that may have generators versus those that have to shelter in other places. This is a picture here of someone that's sheltering in a furniture store that opened up for people to escape the cold. So this whole thing illustrates those interdependencies of social, ecological, and technological systems. And the framework we've promoted in the UREX SRN and adopted and continue to develop in the SETS Convergence project is the social, ecological, technological systems framework. So it's these three domains that I've been talking about, but most important part of that is the system. We need to be thinking of systems as having these components, and most obvious in cities, but I think we could argue that it's the case elsewhere as well. Well, let's turn to resilience. What is resilience? Well, various phrases here that you see encapsulate differing views of what resilience is, ranging from bouncing back to self-organizing and adapting to actually transforming or bouncing forward. The concept is complicated and it's also contested. Not only these views that you see here, but whether resilience is a system property, whether it's a process or an outcome. And as Carpenter et al. Asks, resilience of what, to what, and for whom? We asked the 9 cities that are in the UREX SRN and practitioners and researchers in those cities what their view of resilience was. And I'm just going to talk about this top graph here, which shows the different cities from a more conservative yellow resilience as resistance to the more radical resilience as transformation. And you can see that, first of all, coping is one of the most common beliefs about what resilience is. And then you have a couple of woke cities like New York City and Portland where transformation is a pretty important one. But the point is it's contested across these user communities. And I think that's not particularly surprising given its status and continued redefinition in ecology, which is arguably where some of the ideas of social ecological systems resilience, for example, have come from. So the modern ecological concept of resilience emerged simultaneously with our, as ecologists, recognition of ecosystems as dynamic systems that are undergoing continuous change. So they don't just bounce back to some equilibrium like the rubber band analogy, but rather have multiple equilibria and exhibit thresholds and tipping points and so forth. In social ecological systems resilience, there became this recognition that we need to add features that characterize human society, recognizing social ecological systems as complex adaptive systems. So introducing complexity theory, also introducing governance and power dimensions from social science. In SETS, I think we need to add features that characterize technological systems, but even more importantly, the feedbacks between techno and human spheres. And I'll return to this, but it's an illustration of why it's not sufficient to call techno part of social, which a lot of people argue for. And this is the idea that the speed of system change or system evolution is beginning to exceed human cognitive capacity. So there's this feedback between technology and human capacity to understand it. Meanwhile, concepts in engineering haven't been static, at least for the enlightened engineers that I interact with. Starting with engineering resilience as this idea of fail-safe, that you have this sort of design standard that you build to so that only the most extreme low likelihood event would actually result in failure, and the idea of rebound, moving through to the safe to fail concept where we relax that likelihood criterion and say, well, yeah, some failure is okay as long as we minimize the consequences of those failures. And then to the sustainable engineering resilience, ode to Woods, and a lot of people are in the engineering field are talking about this, the idea that rebound is one component, the return to functionality following a disturbance, robustness or the ability to withstand disturbance within the design envelope of an infrastructure system, Graceful extensibility, which is the idea that the system can function beyond the design envelope, and then sustained adaptability, where the system can evolve over time to withstand and rebound from disturbances that are now both known and unknown, and potentially low likelihood events. So you can see there's some similarities in the evolution of this concept across these areas. And in SETS resilience, we want to move from the single dimension conceptions, which have been very valuable in providing insight into each domain, through the currently fashionable STS and SES framings, to a pluralism and convergence in SETS framing. And we argue that this will allow us to navigate the complexity of the Anthropocene, open up both the problem space and the solution space, and converge multiple diverse knowledge systems. So what do I mean by those four things? First, navigating complexity. Well, the complexity of the framing for solving a problem needs to match the complexity of the problem. So if we have simple problems, they can rely on simple solution. That's fine. And there are many of those that are going on, but that's not the case with complex systems. We need to match, the framing needs to match the complexity. So I mentioned before that SES theories of resilience brought in this idea of complex adaptive systems. How does SETS complexity differ from that SES complexity? Well, the pace of change and the rising complexity in this age of rapid change in the world may soon exceed human cognitive capabilities. And yet we have at our disposal technologies themselves, for example, artificial intelligence, that are some of the perhaps only or best tools that we have to be able to keep up with those changes. Opening up the problem space. And this is the idea that we don't just approach a problem and say, well, let's bring these different perspectives together, but questioning what the problem itself is. So in other words, it's not just a problem of, what's the height of the levee that you need to put in place, but who's going to be affected by putting a levee both downstream and outside the river, for example. So the contextualization of the problem, of what, resilience of what, and for whom. Here's an example from the World Central Kitchen, which is this organization headed by the chef, world-renowned chef, Jose Andres. And the World Central Kitchen is working in poor countries to bring just some very simple technology to the kitchens of mostly women who spend a lot of time indoors or over these stoves with charcoal fuel, being exposed to pollution, having to spend a lot of time there. And what the World Central Kitchen has done is to replace those with some simple technologies that enable women to have safer environments for preparing food, but also providing access to education about these challenges. Another example I'll go into next is some work we've done to frame vulnerability to extreme events across all dimensions to help identify the best places to intervene. And this is work that was led by Hee-Jin Chang at Portland State University. And we compared 6 cities in terms of vulnerability to urban flooding, that vulnerability being a consequence of both exposure, sensitivity, and then reduced vulnerability, reduced by adaptive capacity. And so we developed a series of metrics, which I don't really have time to go into, in each of these domains, the technological, the ecological, and the social domains. And then we're able to get data on these metrics and map vulnerability in terms of social vulnerability that you see here. And I had pointed out Hee-Jin leading this, but Arun was the person who did a lot of the mapping work. Ecological vulnerability that you see here with different degrees of clustering. I don't have time to go into that either, sorry. And then technological vulnerability. So different vulnerabilities for these different domains in these 6 cities. But then what interesting was that we looked for areas where high vulnerability in one domain overlaps with high vulnerability in another. And so these maps only show high vulnerability, either in a single domain, a double domain, or all 3. And there's really very little overlap, as it turns out. There's some overlap in some examples that are shown there, but the correlations are generally weak. And so what that tells us is that focusing on just one or two domains will misrepresent the vulnerability that we see in these cases. Okay, so opening up the solution space, what does this mean? Well, first of all, opening the solution space says, look, there's solutions that come from all of these different dimensions. So it avoids problem shifting and burden shifting, saying, hey, that's the responsibility of the engineers, or that's the responsibility of the social workers or whatever, avoiding things like the blame game in the Texas freeze crisis. Also, the idea of potentially developing equity and environmental codes for projects that are developed along the same lines as the technical codes that exist. So what kinds of criteria do we need to evaluate whether an infrastructure system is delivering on equity and environment? And help us move beyond treating solutions as these sort of binary processes and move toward implementing solutions that address all dimensions. Couple of examples, this one from a place called Caño Martín Peña. This is a canal, an old canal in the city of San Juan. It has sort of filled in and sedimented in, and now is creating lots of flooding problems for the people that live in 8 barrios that have frequent flooding along the sides, both sides of the canal. And with government funding, the idea is to actually dredge out the canal and then expand the greenway so that it's more of a natural feature there, and then relocating people to higher ground. But they're trying to do this avoiding displacement of those people, but rather giving them priority in being able to maintain their locations, or at least their affiliation with these different barrios. Another example, one of my favorites, is Indian Bend Wash, building resilience with nature-based solutions. This was a wash in Scottsdale, Arizona that originally flowed through this farmland back in 1935. But by the 1960s, it had developed housing and businesses along the floodplain. And flooding in the late 1960s was really severe. And so, of course, they called in the Army Corps of Engineers. The Army Corps proposed a big concrete flume that would carry those floodwaters away and handle the 1 to 100-year flood event. And the people of Scottsdale, to their credit, said, no way, we don't want that. Instead, they built one of the first non-structural flood management systems that you see here in the left, this Indian Bend Wash Greenbelt, which provides co-benefits and ecosystem service and access to about 40% of the population of the city of Scottsdale that has walking access to this. And here's the greenbelt from the air. You can see it. This is what it looks like when it floods. It's a safe to fail system. So we're allowing the consequence of that system to exceed its banks, but with minimal consequence. Finally, the hope is that by recognizing these 3 large domains, the ecological, the technological, and the social, this will open up the possibility of expanding even further to invite in knowledges that are potentially crucial to problem solving. We all know that these Anthropocene problems are huge. No one discipline or domain or sector can solve them alone. It's going to require a degree of intellectual humility from all of us in the face of deep uncertainty, from ecologists, from engineers, from planners, and so forth. It's going to require us to elevate marginalized voices and knowledges, acknowledging that we are in a system where power dynamics in our science, in our institutions, exist that sort of promotes some knowledge systems at the expense of others. And we need to work to dismantle those, to adopt this critical pluralism idea. And then I want to say finally that we're really not creating a new silo, but understanding how to work with multiple ways of knowing to solve the urgent and complex problems we face in a rapidly changing world. Well, thank you for your attention.
That was great, Nancy. Thank you so much. Really inspiring and lots of ideas there. Folks, if we have time for a few questions, if folks have them, I'll ask the first one because I don't know if people remembered they have a chance to do that. So put it in Q&A if you want to ask some questions. But Nancy, I'm curious, we've had a fair bit of discussion in the last 2 days about the challenges and opportunities of integrating the social and natural sciences and how synthesis across these disciplines and perspectives and data types has a set of challenges. I've thought a lot about additional challenges in bringing in engineers and other disciplines that have whole different languages and vocabularies and stuff. And I'm curious your perspective, since you've been doing that a fair bit, of where there are unique challenges, but also opportunities in bringing those other disciplines like engineers into the fold of kind of this sets space that you've been talking about.
I would say there's I'm lucky to work with some what I call enlightened engineers, because I don't think I think it's a wave that's moving through engineering, and there, certainly are people that are, open to these ideas, this safe to fail ideas and the ideas of sets, and thinking about resilience in a different way than the standard sort of bounce back, maintain design standards and so forth. They have work to do, but we do as well, because I think we also have in ecology, we have certain biases and expectations about what science is, and engineers are maybe not fitting that mold for us, and so we may have some disdain for the way that they do things. I sometimes point to the old applied basic divide. I don't like to use those terms at all, because I think it's just silly. There's a lot of really interesting fundamental science that we can do that is also directed at solving problems. How to do it, I just think, a lot of times it's really a question of, of relationships, of how you actually establish relationships. And this is going to apply beyond those other disciplines, but also, when we're working with communities or working with, agencies or governmental organizations or others, that it takes time, relationships. One of my colleagues says, built at the speed of trust, right? So it's a slow process, but I think it comes down to that in a lot of cases.
Yeah, great, thanks. All right, questions are starting to come in. The first one, pointing out that the non-overlapping vulnerabilities that you showed are really interesting, and asking if you can talk a bit more about them, especially in terms of guiding solutions or building resilience.
Yeah, so I think starting point is, are the places that we want to guide solutions those that have vulnerability in all three dimensions? Because often the approach to vulnerability is to say, okay, we're going to look at there's different approaches to measuring. Certainly there's some question about vulnerability of infrastructure systems. There's no question that when they're sited, when a wastewater treatment plant is sited on the coast, there's some concerns about how often that's going to get flooded or something like that. But those are usually, use these sort of design envelope likelihood estimates. A lot of the other vulnerability work, particularly in the social justice field, mostly takes a look at people's these three aspects: the sensitivity, exposure, and adaptive capacity of social systems. And I think the one that has the least development so far is the ecological one, actually, interestingly, because what does it actually mean to say that a system is more or less sensitive or has a greater or lesser adaptive capacity? As a person who's worked on, these ideas of resilience and post-flood change in streams for a number of years, I'm a little embarrassed that I don't know the answer to that question, but I think that there's a lot more to do. And in our case, we only had 6 metrics for each one of those domains, and we chose them because we could get data on them to compare those 6 cities. They may not be the best ones, but I think there's probably a fair bit of interesting work to be done in thinking about vulnerability of those three domains simultaneously.
Mm-hmm. Great.
Hope that answered the question. That's went off on a tangent.
Yeah, well, no, it's good. The next one is, do you see a role for proactive involvement by ecologists, for example, offering some solutions that might transform the society and integrate the public better with the environment or elements of it? Do you have any examples of this?
Oh yeah, I mean, I think there's definitely a role for ecologists. Roll up our sleeves and get involved, right? So I can think of some work that's being done in the Verde River in Arizona by the Nature Conservancy. So the farmers there are, they divert water from the Verde, and they are spending, sometimes wasting water. And so the Nature Conservancy has been working with them to have these sensor systems that will allow them to decide when to open the gates and not. The problem is that the river has, these very severe low flow conditions that result from the over withdrawal of water for agriculture. So that's an example. I think, in cities, we have a number of examples of working with communities in Phoenix to try to envision how they would like their neighborhoods to change to reduce the impacts of extreme heat. In particular, giving them, working with them on information about, how vegetation, for example, can reduce heat, and then working with them on their vision. So we actually did this in 3 neighborhoods in Phoenix, the hottest and poorest neighborhoods that we could find. And they created what they called heat action plans, and sort of giving them the power then to take those in. And so I would say that the role of the ecologist there, is to sort of share what you know, but then listen to what they know, and what they like and want, and so it's really a co-production situation rather than one where you're sort of swooping in and saying, here's what you need to do to fix that.
Well, that actually leads into the next, I think it'll be the last question, just so we stay on schedule. But the person asks, if the metrics of vulnerability you use take into account the adaptive capacity of the people that's derived from their local ancestral knowledge. So are you bringing in other streams of knowledge and data and information that accounts for what people know locally?
That would be an excellent thing to do. I would love that as a, because that's a really strong component of adaptive capacity, I think. Both things like social cohesion. So how much are people within an area sort of working together to help each other, but also what is the legacy or the history of the way that they have understood and been able to deal with these things. I think that's really, really important thing for us to start trying to understand. For example, how do indigenous knowledge systems contribute to our ability to better manage resources and lands? But we didn't do it. We used data that were available from the census pretty much.
Yeah, okay. Well, there are other questions. We're out of time. Sorry, we can never get to everyone's questions, but thank you again, Nancy, for that great talk. And we'll pass along other questions to you that people have asked. So.
Well, that'd be great. I'd be happy to try to answer them once my proposal gets in.
So just in the last 5 minutes, I want to give a wrap up and next steps for folks, so people know where we're headed after this. So, first and foremost, just a huge thank you to everyone for your engagement and participation, joining the